Hey everyone, welcome to the Question Show. Your questions, my answers. As always, wherever you are across my channel, if a question pops in your brain, just write it down, gather them up, and I'll answer them here. I'm going to do a early shameless self-promotion for the Patreon for Universe Today. And the reason is because, like a lot of you I know are subscribed to the newsletter, to the podcast, and you read Universe Today on a regular basis, and there's like a lot of ads on Universe Today, and that's what funds the development of Universe Today. But if you become a patron at any amount for one time, so you can just like become a patron and then cancel right away, then you will get the ads removed from Universe Today forever. So your login account for Universe Today will give you an ad-free experience. There's no ads, no trackers, no cookies, nothing. It's clean, just text and pictures. And that's sort of for the rest of your life. So another reason to become a patron, go to patreon.com/Universe Today. All right, let's get into the questions. Of course, I record this show every Monday at 5 p.m. Pacific time. So if you want to join and ask your questions live, just come to the YouTube channel. There should be a link to the next one somewhere on my channel, and you can put that in your calendar and then join us live and ask your questions. All right, let's get into the questions. Diziazi, is there a way to launch a copy of the Hubble Space Telescope? Good news, there is a copy of the Hubble Space Telescope in development right now, and it's due for launch in 2027. And that telescope, you might have heard the name, it's the Nancy Grace Roman Space Telescope. And it is essentially the same size mirror as the Hubble Space Telescope. It has a 2.4 meter primary mirror. And the story of this telescope is kind of amazing. The U.S. National Reconnaissance Agency told NASA that they had two leftover Hubble-class telescopes that they didn't know what to do with, that they weren't good enough for their current purposes. And if NASA had any plans, anything they would like to do with these telescopes, NASA said, yes, please. And one has already been developed into a mission, but the other one is being turned into the Nancy Grace Roman. And this is kind of like a wide field version of Hubble. While Hubble has a very narrow field of view, very high resolution, Nancy Grace Roman has the same resolution, but a 100 times larger field of view. It's specifically an infrared telescope, kind of like James Webb. I know, like so much emphasis on infrared telescopes, but I promise infrared is a very useful wavelength for astronomy. And it's going to be able to get at some really interesting questions about dark energy and dark matter and just sort of the nature of the universe itself. It's also going to be able to find lots of exoplanets. It's going to be able to find asteroids, comets, things moving, things that are visible in the infrared spectrum. It's going to find a lot of planets through microlensing because it's going to have this giant wide field of view and watch for things that are dipping in brightness or lensing. So, like I said, it's due for launch in 2027. So yeah, there's a sibling of the Hubble Space Telescope launching in just a couple of years. And so far it's right on track. Despite the government's attempts to remove it, it's been able to make it through all of the budget issues and is on its way to space in just a couple of years. Well, I guess 5 more years. Vlad Garam. Hey, I have a question for you. I've always wondered if we send a bunch of satellites one after another into deep space, could we use each satellite to send data back to us faster? I'm talking like if we leave just enough space between them to reach each other until it gets to us, something like a repeater Wi-Fi. Thanks. Yeah, this is a great idea. And one of the biggest issues about exploring space is getting the data back to Earth. There's been lots of ideas. You could send a CubeSat out to many locations across the entire solar system, but the problem is these CubeSats are so small, they won't have a very large transmitter. And so even though they could be gathering tons and tons of data at their target location, they don't have any way to be able to transmit this data back to Earth in any reasonable speed. And a good example of that was NASA's New Horizons spacecraft that went to Pluto. It had to take all of these photographs, like as it got closer and closer and closer, it just filled up its hard drives with data about Pluto. But it then took about 16 months to send all of this data back to Earth at about 1 to 2 kilobytes per second. And like, we haven't seen those kinds of slow speeds since dial-up internet days. So it's a huge problem. And you're exactly right that if we had more space infrastructure, we would be able to transmit data around the solar system more easily. And there's examples of this already working. So there is now a network of orbiters around Mars that work to transmit data back to Earth. So you've got rovers down on the surface. They can transmit up to these orbiters, and then the orbiters can relay the data back to Earth using their antennae. And in some cases, the rovers can communicate directly, but in other cases, they can use these relays. And as we get more space infrastructure out there, places around the asteroid belt, places out at the orbit of Jupiter, places out at the orbit of Saturn, in the various Trojan regions, you can imagine this infrastructure building where instead of having every spacecraft have this giant transmitter used to send data back home, it's able to use this relay network to get the data back. But we're looking at a long time to be able to do that because, of course, everything is in orbits. And so Jupiter might be on the opposite side of the sun from Mars. And so you can't relay data through at certain times of the year. So right now it's used in bits and pieces, but over time, I'm sure we will see more and more of this infrastructure coming together. Until then, just bigger and bigger dishes here on Earth to communicate with the satellites. Easy NLX. Question, if Mars was to be terraformed and turned green, how would all those plants survive without protection from the harsh radiation from the sun? That's a really good question, and honestly, nobody has the answer to this. There was a fairly recent study that looked into what it would take to be able to grow plants on Mars. Like, could you just have a greenhouse on Mars where you were growing plants inside? And the answer appears to be no, that the radiation, the cosmic radiation, the radiation coming from the sun is still so powerful, so dangerous, so deadly, that if you had plants in a greenhouse, they would be irradiated by all of this radiation coming from space, and they wouldn't be able to thrive. And so the only way you could actually grow a crop on Mars is to have it underground, where you've got regolith in between you and that space radiation. And so you can imagine, yeah, if we went and planted plants, maybe you start with lichen or cyanobacteria and things like that. Then over time, as you thicken the atmosphere, then it can support larger kinds of plants, and maybe you can eventually turn Mars green. But the factor that you've always got to work against is that this radiation is really powerful. And so maybe there's certain kinds of plants like cyanobacteria, lichens, mosses, molds, things like that, that can survive the radiation or can hide inside rocks and be able to prevent it. But to get things like the kinds of grasses and trees and shrubs that we're familiar with here on Earth, they're going to be dealing with a lot of radiation. Now, one idea is that you can genetically modify the plants to make them more hardy to radiation, but there's going to be limits, and we don't know what those limits are. So I think it's premature now to say, oh, the way we terraform Mars is we just plant plants that are able to handle the environment, and you sort of bootstrap yourself up to a proper ecology, because that radiation is relentless and it is very damaging. And the larger, more complex organisms that you have, the more they're going to fall prey to the effects of this radiation. And I don't think there's a good solution until you can protect Mars with a proper magnetosphere, or if we learn to genetically modify plants to be incredibly radiation resistant, it's going to be a tricky balance. We may never get past algae. Rasmus Abramson. Could Planet 9 actually be dark matter and not a planet? It depends on what your definition of dark matter is. And most of the ideas of dark matter is that there's some kind of particle that is very massive, but doesn't interact with regular matter, and it's spread equally across the universe. And so it wouldn't be collected into any area, and so it wouldn't be an explanation for, say, Planet 9. But one idea for dark matter that just doesn't seem to go away is this idea of primordial black holes. Black holes that were formed at the beginning of the universe, when the entire universe was very dense and you had tiny differences in density that could have spun off little black holes of all different masses. And you can explain dark matter with black holes as long as the black holes are of a certain size range. And I think it's like not more than 1,000 times the mass of the sun and not less than the mass of an asteroid. Somewhere in between that, you could explain dark matter with black holes of those various sizes. And so if it is black holes, then actually you don't need a lot of them. You just need like one black hole per star system's region, and they don't have to be very heavy black holes. On average, dark matter is about an asteroid's mass, like in a size the size of the solar system. It's just there's lots of spaces that are totally empty that would have to have that amount of dark matter as well. And so, yeah, you could explain the gravitational perturbations of the outer solar system by a black hole that is orbiting around the solar system. That said, it's a pretty weird idea, and it would be pretty tough to figure out how a black hole could have gotten into that region, how it went into orbit, how it's remained stable over this time, etc. But there have been some ideas on how you might be able to find a black hole out there if it was an explanation for Planet 9. There would be a slight interaction with the environment around it, the occasional gamma ray coming from material that falls into the event horizon of this teeny tiny little black hole. So who knows? But my guess is no, and I'm sure when the Vera Rubin Observatory comes online like later this year, we'll discover the actual explanation for Planet 9. So stay tuned. Mark Melcon. Do globular clusters ever collapse into disks? Not that we know of. Globular clusters are these accumulations, these collections of stars. They can have hundreds of thousands, millions of stars, and there's a few hundred of them orbiting around the Milky Way, and each one was probably stolen from some dwarf galaxy that the Milky Way gobbled up. We're still not entirely sure where they come from. They might be the cores of dwarf galaxies. It could just be collections of stars. We know that they're old. They're billions and billions, like 10 billion years old. In many cases, they contain stars that are almost as old as the universe itself. And they long stopped star forming. And their shape is essentially due to all of the stars in this region are all orbiting a common center of gravity. So they're all just kind of orbiting around the sum total of all of their gravity. And yeah, if something set them spinning, if they had some sort of interaction with another globular cluster, or they got too close to the supermassive black hole at the heart of the Milky Way, then maybe you could set the whole thing up spinning faster and faster, and then it would spin out. But we see hundreds of them here in the Milky Way. We see them in Andromeda. We see them in other galaxies, and they always seem to be these sort of nice spheres of stars. So it doesn't seem like it's a thing that's going to happen. Tropical Tom Garcia. Is there an intelligent, original interrogatory regarding Lagrange points that has not already been asked 1,000 times on this channel? Oh, you really know this channel. And like, no. I think that every possible question about Lagrange points has been asked and answered in a series of videos. And that's fine. Like, I'm happy to do it. I've done a video series just on the Lagrange points, as well as other videos on Lagrange points. They come up regularly. We talk about it because they're useful. They're these wonderful points of gravitational balance that the universe has provided to us, and we're able to use to park spacecraft and to maybe even be able to shift from world to world without having to use a lot of propellant. So I think it's great. And it shows that for people who are fans of space astronomy and space exploration, the understanding is really shifting to the nuances of the reality of what it takes to do space exploration and how these missions work. We've shifted from when am I going to be able to fly in a warp drive and what kind of spaceship do aliens use, to very detailed, specific questions about the actual mechanics of spaceflight. And I couldn't be happier. So keep them coming. Bring those Lagrange points questions. Simon says 55. Would the rest of the solar system change if you build a Dyson Sphere from the lack of the solar wind? Well, I'll deal with the solar wind issue in a second, but I want to deal with some of the other parts of this as well. So the first thing to understand is that the idea of a Dyson Sphere, of a classical rigid shell around the star, is not feasible. It is not stable. You need to have something orbiting around the sun for it to remain stable. As soon as you create some sort of rigid shell, then it's no longer in orbit, and the star will just drift around inside the Dyson Sphere, melt its way through the side of the sphere, and just keep on going. So you need to have something in orbit. And so instead of having a sphere, what you have is a swarm. You have innumerable spacecraft that are orbiting around the sun at different orbits in such a way that they catch all of the radiation that's coming from the sun. And as part of that, they're going to be interacting with all of the solar wind. The only way to get your Dyson swarm is to dismantle the planets of the solar system to be able to do it. You need raw material, you need asteroids, comets, Jupiter, Mercury. They all have to go into the Dyson swarm factory to produce this Dyson swarm. And as you do that, as you remove planets from the solar system, you're actually making the entire solar system more stable because you're running out of things that can gravitationally interact with each other. And in the end, when you've finished building your Dyson swarm and you have dismantled the entire solar system, you'll have the most perfectly stable situation that you could possibly hope for. Now, the satellites themselves will be having some kind of gravitational interaction with each other as they fly past each other, but you're imagining some future civilization, incredibly intelligent. They'll be able to work out the math on that. But you're right that the sun is still going to do sun things. And some of the sun things that it does is it pumps out the solar wind and also puts out much more dangerous solar flares and coronal mass ejections, which will interact with your satellites. And what's the answer to that? I mean, like just magic, right? Like if you're at the point that you're able to dismantle the planets of your solar system, including Jupiter, and turn them into a sphere of buzzing satellites that are harvesting all of the power from your star, then you will have the ability to deal with the damage coming from a coronal mass ejection and a powerful solar flare coming off the sun. I don't know how, or you'll just suffer some level of electronic malfunction as the highly ionized particles impact one of your Hab rings and people have to turn the power off and turn it back on again. I don't know. But creating the Dyson swarm, dismantling your planets doesn't stop the sun from doing sun things. And one of those sun things is sending out deadly flares and coronal mass ejections, and you won't have a planet-wide magnetosphere to protect you from it. So like future solar system engineers, just like add that to your checklist of things to deal with. Robin Cairo, do you think the new generations of telescopes are going to be able to find Oort cloud objects? No. It's really important to understand just how far away the Oort cloud is compared to the rest of the solar system. When you think about just scales, say the Earth is at 1 astronomical unit away from the sun, Jupiter's like 5, Pluto is like 50, and the Oort cloud is like 10,000, 20,000, 50,000 astronomical units away from the sun. So we won't have any technology for the foreseeable future that will be able to find and image Oort cloud objects directly. The way we find them is when they fall into the inner solar system as long period comets. And then it's just a matter of how early do you detect them. In many cases, they've been hanging out in the Oort cloud since the formation of the solar system. Some gravitational interaction with a nearby star or rogue planet kicks them into an orbit that makes them fall down into the gravity well to approach the sun. And that can take them hundreds of thousands of years to make that journey. But it's only when they're reaching the end of their journey, getting to the closest point of their orbit, that you can actually see them. But, we've talked about this before, that the Vera Rubin Observatory, which is coming online later on this year, we should see first light in late 2022, probably see more science out of it in 23. Its job is to hunt for objects that are moving, changing in brightness, from night to night to night. It will observe the entire southern hemisphere sky every 3 or 4 nights and then do it again at a really high level of detail. And it will see comets before any other observers. It's going to see supernova, comets, variable stars. It's going to see asteroids, and it'll probably be the telescope that finds Planet 9. So for the foreseeable future, the best we're going to be able to do is probably the Vera Rubin. So keep your eyes on that telescope, but we still won't be able to actually image these objects in their location way out there in the Oort cloud. It's just so far away. More questions in a second, but first I'd like to thank our patrons, Matt Woods, Stephen Chandler, Paul Dean, Doug Ingram, Matthew Simone, and the rest of our 796 patrons for their generous support. Want our videos early with no ads? Join our community at patreon.com/universetoday. David Fix, do you think that humans will colonize Mars, or we will need genetic modification to the point that we or they are no longer humans, or maybe even other bodies of the solar system? Yeah, the conditions on Mars are terrible, and especially terrible for human beings. Antarctica, in the wintertime, without a coat is infinitely more habitable to the human body than the surface of Mars. It's a paradise compared to Mars. And so the question is, what will it take for us to be able to survive on Mars? Now, there are some life forms on Earth that can handle the Martian environment already. I talk about good old cyanobacteria. Cyanobacteria is just ready to go. Send cyanobacteria to Mars and it will start growing and be fine. We've got other things, molds, lichens, even like water bears, tardigrades will have a hard time being able to survive and replicate on the surface of Mars. But there are some life forms that can handle it. Definitely not humans. Like, I don't know what kind of genetic modifications you could do to the human body that would allow us to handle brutal radiation, like radiation that is hundreds of times more than we receive on the surface of the Earth. Incredible cold, incredibly low pressure. It just goes on and on and on. So for the foreseeable future, the only way to survive on Mars is going to be able to live underground. The one thing that is a big killer on Mars that we just don't know what the implications are going to be is the lower gravity. We don't know what 35% of Earth's gravity does to the human body over the long term. Will you be able to survive, or does it shorten your life? We know that no gravity is bad for your life. What is 35% gravity going to do to you? We don't know. So maybe I can imagine some future genetic engineers changing the human body to be able to survive in lower gravity. That seems something that's fairly feasible. And yet, on Mars, that's the one thing that we can't solve. You can live underground, you can wear a coat, you can protect yourself from the radiation, from the cold, from the low pressure, but the thing you can't protect yourself from is the low gravity. So I can imagine if we do have human settlers living on Mars over long periods of time, people are going to try to figure out some genetic solution to be able to survive in that low gravity. If it's a problem. If it isn't a problem, then we don't have to worry about it. And then I guess you can imagine the same thing on other worlds. If people want to live on Titan, then the gravity is even lower. If people want to live on the moon, etc. So gravity is going to be the one that I think if we can figure out a way to change our bodies, that would be useful. But then, of course, you might have problems if you try to come back to places like Earth. So I'm not sure if that's what we want to do. Tom Pava. If everything is moving away at the same speed, wouldn't that make us the center of the Big Bang? Yes. You, specifically, Tom, are at the center of the universe, and everything in the universe is moving away from you. But also, everything is moving away from me. And if you went to any one of those other galaxies that are moving away from us and stood on one of those galaxies, everything in the universe would be moving away from you at that point. Everything is moving away from everything everywhere. And so there is no center of the Big Bang. We talk about this every couple of weeks, but I think it's important to keep reinforcing this point until it's all understood, is that you're envisioning the Big Bang as this explosion, right? You're imagining this there's this point and then, sound effects included as it all expanded outward from the single point. But the reality is that imagine instead a grid that goes on forever in all directions. And at the beginning, the cubes on that grid, three-dimensional grid, were very close together. That was the moment of the Big Bang. And then something expanded every part of that grid. All of the cubes in that grid just got farther and farther away from each other. All of the material that was in the universe got less and less dense over time. And so you can imagine if you go to any point in that grid, go to this galaxy over here, go to that galaxy over there, look around, it looks like everything is moving away from you. And then go to another place, everything is moving away from you. And so one possibility is that we are actually at the very center of the universe, specifically that the Earth is the very center of the universe, and that weirdly everything is moving away from us. Or more likely, we're not special, that everything is moving away from everything else. And if you could go to any place in the universe, you would see the same thing. So yes, you are the center of the universe, but so is everybody else. Max, what would happen to a warp drive inside the event horizon of a black hole? Could it potentially escape it? Sure. I mean, the whole point about a warp drive is that it can warp space so that you can go faster than the speed of light. And the definition of a black hole is a region where the escape velocity is so fast you would need to be going faster than the speed of light to escape, then in theory you could use a warp drive to escape a black hole. In fact, like in Star Trek, right, if a spaceship ever fell into the event horizon of a black hole, it would be trivial because they go thousands of times the speed of light. It would be very easy. Like they could escape any kind of black hole. Now, there's one caveat to that. One of the sort of definitions for what a black hole does is that it also tangles up space-time inside the event horizon of the black hole so that all pathways lead to the singularity, to the center of the black hole. And so in a traditional sense, if you said, oh, if I could just go faster than the speed of light, would I be able to escape a black hole? And the answer is no, that in any direction, like if you could go faster than the speed of light, you would just reach the singularity faster because there are no pathways out. But who knows how your warp drive works? If your warp drive actually works by modifying space-time, dismantling, changing, then maybe you could clear a path forward. It all depends on how your warp drive works. How does your warp drive work, Max? Scurvy Sam, could crashing Phobos into Mars help create an atmosphere? I can't imagine how crashing Phobos into Mars would give us anything productive, anything useful for the planet. Granted, you would probably turn a chunk of Mars molten, maybe release a bunch of volcanism. You would send up an enormous cloud of debris into the atmosphere, which would take a long time to settle down. Maybe that would warm up the atmosphere a little bit, but it would cause an enormous amount of damage. So it definitely wouldn't restart the magnetosphere, and you would not have Phobos there anymore. So I would not recommend doing that. The lighter touch is probably the way. Like just block the solar wind. If you can block the solar wind from Mars, then you can stop the atmosphere from escaping from Mars. And then the natural volcanic gases that are escaping from Mars will thicken the atmosphere to the point that the temperature warms up, that the ice at the poles will start to melt. That will put more water vapor into the air, and you will end up having a place that is more habitable than it is today. So no, don't drop Phobos onto Mars. Logic on abstractions. I wonder now that James Webb is likely to have enough fuel for 20 years, what are the odds that a servicing mission will happen to refuel it? Coin flip? 10%? 1 in 1,000? You know, if we do have a 20-year lifespan for James Webb, then it's probably going to be reaching the end of its capability. I mean, obviously Hubble has been going for 30 years, so who knows how long a spacecraft can go for. But if it was only to survive for 5 years and then run out of propellant and drift away, that would be pretty concerning. That said, who knows where the technology is going to be in 20 years? Maybe we'll have regular flights out to the L2 point from the Starship L2 Express. And so then on one of its many missions, it'll drop off a little servicing tug for James Webb and allow it to extend its mission indefinitely. Or it could grab James Webb, bring it back to Earth, and they can service it and then send it back up or bring astronauts. Who knows what'll happen? A lot is going to happen in the next 20 years, I'm sure. So at this point, I think that the limit on James Webb is going to be when the telescope is starting to run down and it just doesn't make sense to maintain it. And that could be beyond that 20 years. I mean, they may come up with some clever ideas on how to make it use its propellant better, to maybe tack into the solar wind or the light pressure of the sun to be able to make its mission last even a little bit longer. So at this point, if it is going to last that long, I don't think there's any need to really service it. It's just going to wear out. Kong, do you think humans will ever visit or fly by a planet other than Mars? I mean, I guess the question is like, what is the value to go to other places in the solar system? Obviously, go up to the moon. It's very close to the Earth. You can set up a base there. You can communicate within seconds. There's lots of good reasons to send humans to the moon. Mars, it's like the most Earth-like place in the solar system, even though it sucks. It's reasonably close to Earth. You can get there in about 9 months. There's good launch windows getting to and from. Phobos is a great place to set up a base. There's really interesting questions about the search for life on Mars. There's lots of good reasons to send humans to Mars. Beyond that, I mean, maybe a couple of asteroids, near-Earth asteroids, would have some interesting things for us to go and explore. And so I can imagine us setting up a base on some near-Earth asteroid. There's kind of no other place that humans really need to go. Now, there's some places that we're obviously very curious about and would love to go if it was easy, which it's not. Places like Titan or Europa or Enceladus or Triton. So there's lots of places across the solar system which would be great to go to, but, living in the cloud tops of Venus, etc. But they're all just bad, difficult to get to, very inhospitable, and probably not worth the benefits of spending our time there. But who knows, in some future, far future, hundreds of years from now, when we've trivialized the exploration of the solar system, we've got incredibly new power systems, we've got an amazing ability to survive out in space, then maybe we'll be able to go to those places on a lark. I mean, there's places here on Earth that hundreds of years ago would have been considered very difficult to reach, like Antarctica. And yet, now our technology kind of trivializes. You can get on an airplane and you can fly to Antarctica. And airplanes were not designed to fly to Antarctica, but that's the thing they can do because airplanes can fly anywhere. So you can imagine some future when we're sufficiently advanced that, yeah, you can pop off to Europa or Ganymede or Titan because you can. And you've got the money to be able to do it. But I can't think of any short-term reasons to go anywhere for humans to go beyond the moon and Mars. And one asteroid, maybe two. Spiro K. The Big Bang was extremely hot. It took 300,000 years to cool for light to travel freely, and we can see the cosmic microwave background. Now it's 3 Kelvin. When it was a nice 300 Kelvin, could have life formed in the clouds. So there is an interesting paper written by Avi Loeb and team about this idea of at a time in the early universe when the entire universe was the habitable zone. And it's about 12 million years after the cosmic microwave background radiation had released. And so when the cosmic microwave background released, the entire universe was about 3,500 Kelvin. It was like the temperature of a red giant star. And then it slowly cooled down over time. And as it cooled down, it eventually reached room temperature. And in theory, hydrogen and oxygen could have come together to form water. And so you could have had water and you could have had the right temperature, but the entire universe was habitable zone. It would be pretty tricky to get life to form that quickly. So, I've talked to Avi about this, and he doesn't think there's any special reason why there wouldn't necessarily be life. But it's such a great idea to imagine that the entire universe for millions of light years was all room temperature early on in the universe. Astria, can you have a moon with a larger diameter than the planet it's orbiting? That's an interesting question. All right, so first, I think it's important to remove this idea of a moon orbiting a planet, because a moon doesn't orbit a planet. A moon and a planet orbit a common center of mass between the two of them. And so if you had two planets that were the same mass and they were orbiting around a common center of mass, right, they would just be going around and around in a circle, and then that they would be orbiting around a star. You'd have this sort of double planet. And we know that Jupiter mass planets are like, Jupiter is like the size of like about the largest planet. Like if you added more mass to Jupiter, it would actually compact down. And so say a brown dwarf, which can have dozens of times the mass of Jupiter, is actually not a lot bigger than Jupiter. And so you can imagine a planet like Jupiter, but much more massive, so much more massive that it's actually compressed down a little more, with a fluffier, lighter planet, like maybe a Saturn orbiting around it. And that lighter, fluffier planet could actually be bigger than the planet and yet have less mass. So theoretically, it's possible. But if you were thinking like a rocky world, then I think no. I mean, rock only compresses so far. So whichever is the bigger world is going to be the one that has the more mass. But in terms of gas giants, I can imagine a scenario where that might be possible. But you wouldn't get like significantly different where you've got the small planet and then this giant moon orbiting around it. You're going to have worlds which are like, this one is 1 times the size, the planet is the size of Jupiter and the moon is 1.5 times the size of Jupiter. So it's a clever idea though. I like it. Stephen Hardy. Hey, Fraser, if the universe has been expanding for a finite period of time, then how can it be considered infinite in extension? Can you square this for me? So the question is just whether or not the universe was infinite at the beginning, before the Big Bang. So it has been expanding for a finite period of time. The universe has been expanding for 13.8 billion years. But we don't know what form the universe took before the expansion began. One possibility is that the universe was finite and wraps on itself, and it was very small, or maybe it was incredibly large. We don't know because we can't measure it. All of our measurements today say the universe is at least as big as the observable universe, probably dramatically bigger. Like if the observable universe is, say, a sphere that's about 92 billion light years across, the actual universe is at least 1,000 billion light years across. But it could be way bigger, and it could be infinite. And so at the beginning of the universe, it could have been infinite, or it could have been finite, but really big. And then it has been getting less dense over time as things have been moving away from each other. And we also don't know what was the state of the universe before the Big Bang. So how does something come from nothing? Well, maybe the universe was in some pre-state before the Big Bang for a very long period of time, maybe an infinite amount of time. And then it fell into this current state. Or maybe there's some kind of cycle that goes on that's been going on forever. We don't know. Like, we just don't know what the answers to some of these questions are. And that's fine. And we may never know. And all we can do is just say, like, we don't know. Let's try to find out the best we can. And that's all that astronomers and cosmologists are trying to do, is just try to answer questions, knowing fully well that they may never find the answers. All right. Those are all the questions that we had this week. Thank you, everyone, for writing them down across the YouTube channel, everyone for joining me on the live show and answering their questions in person. This is super fun. Again, if you want, I do this show every Monday at 5 p.m. Pacific time. You can join live, ask your questions, ask follow-up questions, join in the banter. The show's about triple the length than what you see as the final finished question show, so it's a lot of fun. You should join us live. All right, we'll see you next week. If you want a single comprehensive resource for space news, you'll want to subscribe to my weekly email newsletter. Every Friday, I send out a magazine of space news with dozens of stories, pictures, brief highlights, and links so you can find out more. Go to universetoday.com/newsletter to sign up. It's totally free. And did you know that all my videos are also available in a handy audio podcast format so that you can have the latest episodes as well as special bonus material like interviews with me show up on your audio device? Go to universetoday.com/audio or search for Universe Today on iTunes, Spotify, or wherever you get your podcasts. And I'll put a link in the show notes. Thanks to all the moderators, and a special thanks, as always, to Chad Weber and Nancy Graziano.